Good afternoon, everybody, and welcome to the 10th session of the summer term 2024 of Sonoikisis's Digital Classics and Byzantine Studies. The topic of today's session is handling of sigillographic data through XML, machine learning, and decision trees. And it will be presented by our two colleagues and friends, Alessio Sopracasa from Sorbonne University and CNRS in Paris, and John McEwan from the St. Louis University in Missouri. If you're watching this live, as always, please say hi and tell us where you're watching from. And after the session, when we will have our discussion round, of course, feel free to ask question via the live chat. Having said that, I think that we should start also because it's a topic that, is very close to my heart for a series of reasons. And I think I will leave the floor to Alessio, right? Yeah.
Thank you. Thank you very much. Thank you, Martina. Thank you, Monica. And thank you, Gabby, for this invitation. I'm very happy to be back at Sonoikisis this year. As you can see, in what I'm about to introduce you is what we are currently doing in a project called Digibit Seal about the handling of sigillographic data coming from Byzantine seals. Which corresponds to the first part of this lesson, mainly about XML. The historical context of these kind of objects, you can see one of them here, is the Byzantine Empire, the former Eastern Roman Empire, going from the 4th to the 15th century. It's one could say that Byzantine Empire was had a very developed sealing culture, sealing practice used for especially, but not only, for the daily administration in of its church, its civil administration, and in the army. What is interesting about our seals is the information they carry, which is engraved on them, and on very, very small objects, actually round, with an average diameter of about 20 to 30 millimeters. So they are very, very, very small, mostly made of lead, with a few exceptions, for example, gold for imperial seals. And they were attached to the documents, letters or official documents issued by the three main branches of the Byzantine administration. What is extremely important to know is that we have lost the most part of the Byzantine archives, so the most part of the documents. But what we have, it's a very important number of seals attached to those documents. So we only have the seals, with a few exceptions, but not the document they were attached to. Basically, the Byzantine seal had inscribed the name of the person belonged to the church, to the army, or to the civil administration, issuing that document or sending a letter. with the entirety of his titles and especially functions. So the offices, its office, its work, actually, its position in the Byzantine administration. And this give us a extremely important and necessary source for the understanding of the functioning of all the Byzantine Empire, with information, objective information, not given by other kind of sources, including obviously the names of the persons, first name or family name, when in a few cases, and mostly it depends on the period, on the date of the seal. They can have a different layout, but basically they are conceived on the basis of three main elements: an iconography, an image, a legend, an inscription, and a monogram. In this case, I'm going to show you very quickly three examples. You have here an example of one iconography depicting the Virgin Mary and the Christ on a chest, and you can see, and you can see it here, and the legend bearing the name of the issuer, of the owner of this seal, Nicholas Mesaritis, in this case. The other possibility is to have a double iconography. This is an imperial seal of the Emperor Alexius I, belonging to the Convenors family, with the Christ and the Emperor itself depicted on the reverse. The other possibility is a monogram. You can see here, monogram is, there are a few letters composing a word or several words. In this case, an invocation to the Mother of God, Mother of God, help. And it's a standard invocation on Byzantine seals, and the name and function of the owner on the other side. This seal belonged to Leo, governor of the region called Chaldea. So this is the way a Byzantine seal can look like. So how those seals were produced? Well, the lead was poured into these molds, this kind of molds, having different diameters, and you can see here a place to create what is called a channel. There were a metallic strip here and used to create a channel, a hollow channel inside the seals, where through which the seal was attached to the document. So with this kind of molds, a blank was produced, and you can see here the channel, and the images, legends, or monograms found on seals were left by this kind of object called by the Byzantines a bouleuterion, so the matrix, with the negative of the inscriptions or images engraved on the two faces here. And after that, once prepared, the blank was inserted between the jaws of this player-like object, and this object was struck with a hammer, and the image and the legend were impressed on a seal. So that's why we use the term seal for both the object and the imprint, and for the imprint itself, which is a simpler way to use this kind of vocabulary. But one has to be aware that seal can mean these two aspects: the whole seal plus the imprint, or just the imprint. So this is our material. This is the object of our research, and especially the information, the data coming from these objects. And this is also so the handling of this kind of data is the aim of this project, a French-German project between Paris and Cologne, called by an acronym DigiBiz Seal. What I'm going to talk about today is the digital objective, which obviously is also based on the sigillographic one. This means that we, in order to create a digital, the possibility to have a consistent, sounded, and scientifically appropriate digital edition of seals, we need some material to work on, giving us ideas and also obviously problems to be solved. That's why we choose a corpus of ideally about 4,000 seals, partly already published, partly unpublished, which is going to give is giving actually us the critical mass of data in order to develop our digital approach to Byzantine sigillography. Byzantine sigillography is a discipline, a quite recent discipline, born in the 19th century, and it has never had until now a real digital life. So the idea at the basis of this project is to get this digital life, to have a proper digital Byzantine sigillography. And there are two, as you can see here, two main concerns about sigillography and about the handling of data coming from Byzantine seals. First of all, there is a lack of shared rules for a consistent scholarly edition done in in ways, let's say, in always the same way. But Byzantine sigillography is also a discipline without a real handbook. So with a lacking of general thinking about what Byzantine sigillography can be as a real discipline. And this is not just, obviously, a digital problem, but we think that the digital approach is today the main way to get this kind of to get a real discipline with sounded and shared basis. And on the other side, there is a lack of an important corpus of Byzantine seals. In each discipline, huge corpora are a priority in order to establish not only what I was talking about until now, but also to have a proper work of edition and historical commentary about this material. So what we are trying to do is to address these two main issues of the discipline in different ways. And the first problem, the first issue, is the lack of common and shared rules. This has always been for us the first concern. The answer to this problem has a name, SigiDoc, and it's not an idea born with our project, our DigiBuild project, as you can see from here. To have from this slide the idea of having a common digital way to edit seals and share our sigillographic data and material date back to the beginning of the century, actually, and this went through several steps, but it's only between the 2015, 2017, and today that this approach started to be really addressed and to become to take life, actually. So what is SigiDoc? If you are acquainted with Epidoc, all this will be familiar to you. It's a data model based on the XML, the Extensible Markup Language, which is a language very appropriate in order to store, to transmit, and to work on our material. It's a semantic language, markup language. This means that it is interested in the meaning of the data coming, in our case, from a Byzantine seal. Is less interested in the appearance. And the starting point for SigiDoc has been the well-known Epidoc experience. SigiDoc is today a subset of Epidoc. And the sigillographic is now in its 2.0 version, which is currently being tested after 1.0 version. The first release of sigillographic was in September 21, and we had also an intermediate version in a couple of years ago. So those are the main components, to say it very shortly, of sigillographic. This is the first tool, if I may, if I can use this word, developed to properly manage and handle our data. Those data in our project comes from published and unpublished materials, and this forces us to face many problems, especially when working on already published material, because this lack of common and shared rules is very explicit in already published material. So, and the task is for us to adapt the different choices made by sigillagraphers in their paper publications, to adapt them to our data model, to sigillographic. And the action itself of having one data model with given rules compared to the variety of solutions to edit the same things adopted by sigillagraphers was an important challenge in transforming these paper publications into digital publications. And this led us also to improve our guidelines and our template in order to be more consistent and to avoid the same problems highlighted by paper publication, which are actually which play a key role in the development of our data model. This is just an example. I can, without spend too much time on this, but as you can see, this is the seal with different lines. This is what we call a diplomatic transcription. This means the letters and the lines as they appear on in this case, the reverse of a seal, and this is the final transcription, the editorial transcription, the editorial edition with the editorial interventions, with solution of abbreviations, with lacune, the reconstitutions of lacking text, etc., where possible. Of course, is not always possible. But as you can see, it's very difficult to align the two kind of transcriptions, which should be aligned, especially because the criteria chosen to highlight some problems, objective problems on the surface of the seal, are not very consistent and not very clear, and it's difficult to know what a white space, for example, can mean. So it could be a good solution for the editor itself, but The idea is to communicate the reader with symbols, shared symbols, which tells something to anyone. And this is what we did in transforming, actually trying to align this this editorial final editorial edition to the diplomatic, giving some symbols able to speak to the readers, but they are also symbols and solutions not so much used by the Byzantine sigillagraphers. This is also one of the major problems of our discipline. Again, if the aim is to have harmonization, to have common shared rules, this explains the choice made by our project to use for the diplomatic transcription. So the letters are on the seal of a specific font called Athena Ruby, developed by an important research center for Byzantine studies, Dumbarton Oaks, in Washington, D.C., and which also has the most important collection of Byzantine seals in the world. So when it comes at this is what is the Athena Ruby palette today. So all the different glyphs available. If I may, I could show you better like this. This is the homepage of this font, and here you have this palette. So in the approach to the diplomatic transcription, so the inscription as it is on the support on the seal is typological or visual rendering. Typological is just to say it's an alpha. So we know that it's what kind of letter is. The visual rendering wants to be more precise, and you can see here how many all these until here are variants of the alpha. Variant letter, and those are all alphas, but all those letters are attested on seals. And they could be used in order to have a better better diplomatic transcription. Besides that, there is also dating questions related to the use of a particular variant. You can see it also with this letter mu, the ni, the omega, etc. So those are different approaches. Athena Ruby is almost new font. Many sigillagraphers choose simply to have a typological rendering, so it's an alpha. I put just a standard alpha. You can click to have it. This it's sure. because sometimes the state of preservation of seals hinders the possibility to choose to pick among the different variants. But the choice made by Sigidoc first and by the DGB seal project is to try, as far as possible, to have a more precise representation of the letters, which doesn't mean that we are going to have drawing of those letters, but we just should establish that a specific letter form is a real variant and not just a different way for an engraver on the matrix to engrave an alpha or this kind of alpha or this other kind of alpha. So the idea is not to have any minimal changes, every small changes in letter forms, but to establish through experience and comparison which kind of variant can be considered as officially as a variant letter and not just something the engraver, as I said, did a bit differently. So to go back to my this is just an example of how standard paper sigillographic edition looks like, but it's not so important for us. I would have liked to show you the digital conversion of these editions, but unfortunately, right now the website is offline. So I'm very sorry about that, but I noticed that last week, and we're about to solve the problem. Obviously, digital publications has a lot of positive points. In my opinion, only positive points if compared with the paper editions. And here you can just read and see the most of them. It's in a certain way a never-ending work, but this doesn't mean that we don't have specific version of this work, which can be cited as they are as a scientific publication. The decision taken was also to align our schema, so the rules according to which our Sigidoc edition of seals should follow to the Epidoc schema. Through what is called a chained ODD. ODD is an acronym for One Document Does It All. To say it quite simply, is a way to take what is what is in the Epidoc schema and only introduced changes or modifications to this schema to adapt it to the needs of Byzantine sigillography. And this means that the Sigidoc XML editions will validate against not only the Sigidoc schema, but also the Epidoc and the TI schema. This also means that through Epidoc, Sigidoc belongs to the huge family of the text encoding initiative. There is also other solutions and tools we are developing in Digibit Seal project to manage our data and to prepare the XML edition of a Byzantine seal. This is what we call a tagless editor, which currently looks like this, but is under development, as you can see. But the idea is to have on the left side exactly the structure of our template, of the sigillog template, with all the data necessary, and on the right side, the pre-visualization of what this XML file will look like on the final web page, taking into account, obviously, our style sheet responsible for the transformation from the raw XML file to the web page. But the other important issue to be addressed by the project, as I said, is the creation of a huge corpus of Byzantine seals. Obviously, the idea is not that only one person or only one team is able to do that. It's impossible. And the idea is to share all the file the foundation files we are creating, we are producing during this project, to all the people and project interested in editing, digitally their material, the Byzantine seals. This is we use this tool, if I may, called FS, Epidoc Frontend Services. It's a platform developed first to customize Epidoc files and in order to get in the end a raw web page. A raw web page of a raw website, actually, with your corpus, with indexes and search forms. And sigillog contributed to the development of this platform. And to also this future huge corpus, virtual corpus, will be based also on authority lists. These authority lists are XML files holding all the important data coming from our seals, dignities, offices, place names, personal names, etc. All the data a project considers as important will be integrated to common and shared authority list, shared among all the project using sigillog and the digital infrastructure about to be created by the project Digibit Seal. I can skip this part because the ultimate goal of the project is the creation of we call a federated search portal. This means a kind of meta portal through which all the collections and corpora edited with sigillog will be searchable and virtually unified. it is important to know that the use of FS, even if recommended, will not be compulsory. A project can also have simply XML raw data, an XML repository, and this will be enough in order to perform a search and to find the data. This is in our opinion, the most effective way to get this corpus of Byzantine seals, giving to anyone the independence and the freedom of manage their own material, but at the same time giving them the possibility to merge it virtually with the other similar endeavors and to benefit, to share among all the interested researchers and persons. So you will be able to, all this is for now in GitHub repositories to which we share our foundation material, and in which the different corpora will be the data coming from the different corpora will be present, and they have their own repositories. And from there, this future meta portal, which doesn't exist for now, will take all the information. So thank you very much. It was a bit too long. I'm sorry, John. Thank you for your attention. Thank you very much.
And I will give the floor to John in 1 second. Yeah, there you go. Thank you, Alessio. John, please.
Hello. Can you hear me? Am my sound good? Sounds good. Okay, I shall begin. Thank you very much for the invitation to contribute to this seminar series. What I'm going to offer today is an introduction to the DigiSig project. And I'm not doing this because I expect that you will be using this. I imagine that most of you in the audience today are Byzantinists or work on antique seals. But this is a project which is largely concerned with seals from medieval Britain, and it may offer you perhaps some useful lessons, examples, and potentially even inspiration of the kinds of things you might want to do with the kind of seals that you work on. Hopefully there's enough overlap between the kinds of seals and the problems that we face that we can mutually inform each other with our experiences. So what I'm going to do is I'm going to offer a quick introduction to the nature of the material that dominates the DigiSig project's data set. Then I'm going to move to thinking about the kind of research questions we have traditionally put to this kind of material, and the ways in which the digital version of the project seeks to address those questions. And then at the end, I'm going to hopefully get to a bit where we're going to talk about some of the more recent experiments we're doing with machine learning and decision trees. So let me begin. So here you go. Here's a medieval seal which incorporates an ancient gem, a seal stone manufactured in the ancient world. And I want to start by giving you a sense of the kind of material we're dealing with here. So this is a very, very posh seal, but you can see the kind of standard configuration. We have some text around the outer edge, which may incorporate the name of the person whom the seal represents, or it may have some other kind of invocation or motto. And at the center, there will be an image. It may be, in this case, it's a bust, but it can be almost anything that someone feels would be a good image to have on their seal. This is a seal matrix, which is the device used for, it's like the stamp that is used for making seal impressions. And so you can see at the very top, there is the indication of the handle of the seal matrix. And if you were to flip this over, you would see it has a back, which is also made of silver. So in the DigiSig project, we have seals mainly in two forms. We have seal matrices, which are the ones that you're probably most familiar with and are most closely akin to Byzantine seals we've just discussed. These are the stamps. They often survive archaeologically. In rare cases, you might find a seal matrix with the chain still attached, as you can see there on the left. More commonly, they are just kind of flattish metallic discs that are recovered from people's back gardens or within an archaeological dig, perhaps discovered on the riverbank, and they are passed to an archaeologist or museum, and they may end up in a museum collection, where they may end up on display. So on the right-hand side, you can see a few examples of medieval seal matrices, and what the museum has done to make them a little bit better, easier to understand, is they've made an impression in red of those seal matrices to show you how the design was supposed to be expressed when it was printed. Here's just another example of a seal matrix incorporating an ancient gemstone. In this case, there are photographs of both sides of it, the front and back, so you get a sense of how it's structured with the handle and the seal stone and the writing around the outer edge. And this is an example of how you encountered them when you're working with them as a researcher. Here is a tray of seal matrices that are held in a museum that I consulted at one stage. You can see them packed in there, all next to each other. And I wanted to bring this image in because I wanted to suggest to you that there are large numbers of these. For Britain alone, you're probably in the order, at the moment we know of thousands of seal matrices from the Middle Ages. So quite a significant number. However, although we have thousands of seal matrices, the stamps used to make seal impressions, we also have vast numbers of the impressions as they are applied to documents to create these seal impressions. So here the idea is that someone drew up a document, an important document that preserves information about a transaction perhaps. A property conveyance is a very common sort of document to survive with a seal appended to it. There's a tag at the bottom to which is attached a wax impression of a seal matrix. In this case, I think it's a seal of St. Paul's Cathedral. If you're working with these as a researcher, they will often come to you in boxes. Archives hold hundreds of thousands of medieval records with their seals still attached to them. Here is an example of a set of seals I worked through at the London Metropolitan Archives a few years ago. Thousands upon thousands upon thousands of these. We actually do not know how many seal impressions there are because no one has ever counted them. So, what can we do with them? Well, I think to begin, we need to get some sense of what these things meant in their original context, what they meant for the original owners. And in the first instance, people in the later Middle Ages are using seals to authenticate and to validate documents. So they have a legal significance. At the same time, because a seal is a means for someone to convey text and image, many people also use them as an opportunity to say something about themselves. What they say can vary from situation to situation. Someone might want to make a statement about their social standing, their occupation. They may want to indicate who they're married to. They may want to make a joke. It could be a humorous seal. All these are possibilities. So if we look at, for example, royal seals, they say very clearly that the person whom this seal represents is the head of the political community. That is sort of the point of this seal. It is grand. It depicts a man on a throne exercising authority. Bishops do very similar sorts of things in that they have very ostentatious seals with elaborate decoration and depictions of bishops on the front of them. Some people use ancient gems, as I already mentioned. Here's an example from London, probably of someone who is involved in the mercantile community using a recycled ancient gemstone as their seal. Here's an example from the 14th century, a seal with a shield of arms presented as its central motif. And not to give you the sense that the misleading sense that everybody was grand who had a seal, at least in medieval England, seal usage spread from the very top of society down to quite a low level. Because they're used in judicial contexts, anybody who has legal rights may have a seal. So even quite humble people have seals, and the kinds of images that are depicted on them in some ways evoke that lower level of social standing. So this is our body of material that I'm working with. Seal matrices, which are the stamps, and seal impressions, which are the expressions or manifestations of those matrices as attached to documents. Now, if you're a researcher, what are the kinds of questions that you can sort of put to this material? I've already suggested that it's a good way into thinking about the ways in which medieval society structured and organized itself and what kind of groups it defined and how people align themselves with those groups. Indeed, one of the major areas of research with seals is as a complement to prosopography. People look at the seal of the person they're interested in to find out something about them. But there are lots of other things you could conceivably do with these sorts of sources. For example, here's a 12th century example of a seal that depicts a standing woman. You can see that hanging from her arms are some very, very long sleeves. In the mid-12th century, this was a thing that people did. They had very long sleeves. It's a way of ostentatiously demonstrating their status. If we go forward a few decades into the early 13th century, you can see that this depiction of a standing woman does not have very, very long accentuated sleeves. The ways in which people dress have changed. So we can look at seals, for example, to study the ways in which clothing evolved. That's just one possibility. Another thing you might do is you might take your data and explore its geographical patterns. You might say, where do seals with certain kinds of images turn up, to see if you can discern patterns. I'm just showing you a map here that I created a number of years ago that was exploring where we had examples of seals depicting an armored man on horseback. In addition to looking at variations over space, you might look at variations over time. Here's an example of a graph I produced for a project a number of years ago where I was exploring seals in Wales, and I was interested in the kinds of seals that were common. And the solid line represents seals with the kind of fleur-de-lis or stylized lily motif on them, and the dotted line represents seals with those shields of arms on them. And you can see that the relative, I want to say, popularity of these seals, or how common they are in our data sets, changes over time. We go from, in the early years, from lots of stylized lilies or fleur-de-lis, they drift off, and they replaced perhaps by these shields of arms. Okay, so this all sounds very exciting. We have all this wonderful material, thousands of seal matrices, hundreds of thousands, perhaps millions of seal impressions. They enable us to engage with lots of different kinds of questions about late medieval life. How do we work with this data? Well, most of the data is contained in finding aids that are produced by the various repositories that hold these objects, the seal impressions or the seal matrices. And so if you want to sort of look for a person's seal, for example, you might have to look through an awful lot of books running the same query over and over again, trying to find a seal of the person you're looking for. Now, obviously, that's hopelessly inefficient. And so this is where the DigiSig project sort of comes from. It stems from my own need for a tool that will enable me to survey large numbers of finding aids and repository guides and research data sets in an efficient way. Now, the DigiSig project, I'm going to give you a little bit of history of it because I think it might be of interest. It originates actually in an AHRC-funded project called Seals in Medieval Wales. And the PI in this project was Professor Philip Schofield at Aberystwyth University, and the lead researcher was Dr. Elizabeth New. And I was very privileged to be hired, this would be back in 2009, to work on this project. And the aim was to gather a corpus of seals from Wales in the later Middle Ages to enable us to speak about the ways in which seals reflected the people of that region. For that project, I built an information management system. Here is a fascinating screenshot of our internal interface for this. And you can see the date on this is 2009. It's going back quite a ways. And when we completed that project, this would be a few years later, we did a number of things. We put on an exhibition at the National Library of Wales. We published a book, did a whole series of public workshops. And at the end of the project, I was left with the data set. At that point, it was on a server at the university. It had been used by the researchers on the project to produce various materials. And my thought was, well, let's keep going. Instead of just doing Wales, let's start to pull in additional material. Let's pull in catalogs of seals in the National Archives. Let's pull in catalogs of seals from the British Library, the British Museum. This work that we had done on the Welsh seals could perhaps form the foundation for a much bigger, broader project. And that's how we get to DigiSig, because a few years later, this would be about 2013, 2014, I produced the first version of this system, which enabled you to search not just for Welsh seals, but seals within Britain more widely. I'm just going to skim through that. Now, underlying this particular system is a set of cataloging concepts. What we're doing here is, in the first instance, is making a distinction between the seal as an image, an object, image, text, dimensions, sort of, you might say, the abstract concept of what is represented on the seal, what the seal represents, conveys in terms of information. This is distinguished from the impression of the seal matrix, which has a certain condition, and it forms part of an object, an item, something that's in a museum or an archive. And if we expand that concept, we can start to do things like link these things, the seal, for instance, to records for people or events. So what we're doing here is we're taking inspiration from the world of linked open data to try to structure and organize our information. And so that brings us now to the current state of DigiSig. So if you go to it today, you'll see a form that looks a little bit like this as your entry point. If you're curious, this is built on Django with a Postgres database in the background and a leaflet for maps. And what the website now offers you is a whole host of ways of searching and engaging with this material. There are forms for searching by place, or by the person, the actor involved, or something about the characteristics of the impressions, or what catalogs have described them. So in effect, what we're doing here is we are taking a lot of the traditional functions that the printed works did, but we're generalizing them so they apply to all the different works, and we're making it very convenient to search everything all at once. So it's kind of like a better version of our printed works. But there are certain things you can do online that you could never do in a print edition. So we're starting to kind of play around with those sorts of enhancements. We're adding things like RTI images. There's an exhibition area. I encourage you to go play with them. They allow you to work with the images of the seals in a way which is pseudo 3D, you might say. We're starting to provide you with statistics that allow you to look at very large groups of seals, whether that be a collection, a research collection that's already existing. There are reports that show you, their geographical distribution. So this is very hard information to sort of grasp when you're just reading a catalog, but it is very useful to have it visualized for you so you can have a better sense of what each collection contains. But I'm also interested in sort of pushing things further, not just making better editions of these seals, larger editions of these seals. I'm interested also in thinking about how we might start to use this mass of data that we've accumulated to think through the history of seals and getting the computer to help me. So for my kind of last bit of my talk today, I'm going to talk about a problem I'm currently working on, and that is the dating of seal matrices. Now, as I said at the beginning, our seal matrices are discovered largely archaeologically. They may come out of the ground. And when they do, they don't have really clear information about when they were in circulation. That is something which we have to make an argument for. And the way in which archaeologists and museum curators do this is they look at the seals, they look at their handles, they look at their sizes, their metals, they consider what's depicted on them, their writing and their images. And what they do is they think, when are other things like this in circulation? And then they say, well, if things like this were in circulation in this period, this seal here, this one we're talking about, is likely to be of the same period. That's how they go about assigning a date to it. Now that is hard work, but it's ultimately based upon the data we have from the seal impressions, because the seal impressions are all attached to documents, and the documents tell us sometimes exactly what day they were in circulation. They tell us when the document was made. So my proposition is, why can't we automate some of this work? Get the computer to go and look for seals which have similar features to the one in question, and come back with a report and say, well, this is when I think the seal was probably in use. So the computer solution to this is to adopt a set of technologies such as machine learning. And it is not necessarily the most coding intensive work to use machine learning these days. There are some wonderful libraries for machine learning. I've just attached here a screenshot of the little bit of code in DigiSig which creates the machine learning model, the decision tree that we're going to be talking about in a second. And I just wanted to show you how short it was. Now, there is lots of work that goes on behind the scenes to organize and structure the data. And there's lots of work that goes on in terms of formatting and displaying the results. But this is not necessarily something that is going to require a computer scientist to do. A lot of us are capable, if you know a little bit of Python, for example, to do this sort of work. So in this case, I wanted the computer to help me date the seal matrices. And so what I did was I submitted to it a spreadsheet of data with information about the seals that are already dated, the ones, the seal impressions. And I asked the computer to create a decision tree, which would structure and organize the cases as best it could into groupings where the seals had similar features and similar date. And here's just a graphical representation of the shape of the decision tree. And once it creates this decision tree, it allows you to run cases that the computer has never seen before such as our archaeologically discovered some matrices, and get a date output. It does so by following what is called a decision path, where it starts at the top of the tree. It is confronted with a series of decisions that have yes or no answers, and at the end, it associates the seal with another group of seals, basically, which have a certain date. So in this case, we have a seal which is pointed oval. It's got a radial motif on it. It has a certain size, and you can follow this through and get to a date of something like late 13th, maybe early 14th century. Now, here's just another representation of that in a textual form. Now, these dates that the machine is coming out with are produced through the aggregation of lots and lots of cases. And so there is actually a kind of a distribution curve underlying the date prediction. And so DigiSig at the moment shows you that distribution curve, so you get a sense of how likely it is that your seal, it's probably in the center, but it could also be a little bit earlier or later. Now, this might sound like that this system I've just described to you might sound like magic. But before you trust it, you also need to test it. So the computer may have created a decision tree which helps you think through this problem of what is the date of your seal matrix, but it'd be a good idea to see if it actually produces results that are sensible, or at least comparable to those that a human being might present. And so my last section here, I'm going to talk a little bit about some seals that I love. They are here. Here you can see an example of a rabbit sitting on the back of a dog, blowing a horn. These are known among sigilographers as the hare on the hound or the hare riding the hound. And they are, we know from the impressions that these things turn up in the first half of the 14th century. And they evoke the concept of the world turned upside down. So to test my decision tree, what we're going to do now is we're going to ask it to date some seal matrices that have already been dated by scholars and published in seal catalogs. So the first one we're going to look at is this collection called the Schoyen collection by Richard Linenthal and William Noel. And in the Schoyen collection, there are 4 examples of these seals with bunnies on the backs of dogs. And Linenthal and Noel date all of them to the first half of the 14th century. The decision tree in blue dates them a little bit more broadly from kind of late 13th through to the late 14th century, but it's in the same neighborhood. So that sounds promising. Let's now try comparing the results with the Portable Antiquities Scheme. Portable Antiquities Scheme is a wonderful resource. It assembles information about seals that are discovered by members of the public. It's a vast data set, but it is not as intensively curated as published editions because the archaeologists are very busy and they produce lots and lots of material very quickly. If we run the same kind of test there, where we ask the machine learning decision tree to date the some matrices, you get this sort of output. The archaeologists in the Portable Antiquities Scheme tend to be dating their hare on the hounds a bit more broadly than the machine learning one does, but they're in the same neighborhood. So that's a very, very quick little tour of the DigiSig project. What I've tried to do is to give you a sense of the history of the project, the kinds of research questions that scholars can use the system to engage with, but I also wanted to suggest that it's only the beginning and that we might start to use these sorts of data sets to solve problems that we never thought in the past we could tackle, such as redating or challenging the dating of very large corpuses of seal matrices. And I think I'll stop there.
Thank you so much, you two. This was amazing. I definitely learned a lot. Wait, I will put Alessio back on stage. Hi, so there is all of us. Perfect. So we still have a couple of minutes for questions, both from the audience. If you have any, as usual, please write them in the chat. Yeah. Otherwise, also comments from our chair persons. So let's wait for some questions to pop up. And yeah, I mean, Gabby, please, there you go.
Thanks. No, I really enjoyed both of those. Obviously, I've come across SigiDoc before, but we're very pleased to see the stuff about the DigiSig project, especially as I saw, a handful of those matrices from one of our local collections only last week. So it's a lot of fun to know a bit more about them. I was particularly interested again in your machine learning exercise at the end there, which looked really promising. And I assume that when you've got that very slight sort of discrepancy, as it may be broader or narrower or whatever than the scholars between the scholarly date and the machine predicted date, I presume that can both be part of the next round of training data, as in you can say this isn't what scholars predicted, therefore improve future results. It could also presumably sometimes, especially in a case like, for example, the portable antiquity scheme data, which if, as you say, is maybe doesn't have quite the attention that scholarly editions might. It might be a way of testing those results. If you see something that is very different, let's just have a quick look. Do we agree with the human who was in a hurry, or do we agree with the software in that case? But what I've always assumed is that the really interesting thing is where you see a discrepancy between what the machine would predict based on just what it's seen and been trained to see, and what a human actually says, because that can actually lead you to not that one is necessarily better or worse than the other, but that has something interesting and unusual about it, and that's where we come in, right? As scholars looking at those sort of results. So I wondered if you could think of if you had any examples of where just that sort of discrepancy just led you to make new interesting discoveries about some of those seals.
Yes, that's a fabulous set of questions, and it's a big set of questions, and I can't really address all of them all at once. So let me just make a few observations to begin with. The machine can take into account all the data we have right now at this moment in time, but every published edition is created at a certain moment in time, and then it's fixed. So that's often an issue. The longer time goes, the more likely it is that the machine is going to know more about it than the original editor. Secondly, the machine is very good at dealing with certain features of the seals, things which are easily quantifiable or classifiable. What DigiSig cannot do right now is look at the text and say, what is the style of the lettering? Because that's not actually in any of the printed editions that it is ingested. A human being would look at the style of lettering and say, oh, well, this is black letter. This is quite typical of the 15th century. So the human is almost always going to be better than the machine in isolation, because it can just take into account more things than the machine really can. But the machine is really, really good at doing things like dealing with sizes and shapes, really fine differences in scales and sizes. That sort of information, it might be written in a printed edition. You might read it that this is 12 by 15 millimeters, but a human being is just not going to appreciate that, kind of internalize that kind of information to be able to make to really fully assess it. So in a way, what you want is both. You want the human being to look at the style of the image, the style of the lettering, the overall appearance of the object, its impact, its kind of current cultural, they bring that kind of understanding iconography to it. And then you want the machine to do stuff like really plow through the information about the sizes and shapes. The machine can definitely get tricked by seals which are deliberately looking archaic. Sometimes people create seals to evoke earlier periods, and the machine will just fall flat and not understand it at all. Human being will never get tripped up. But I think this, but I want to go a little bit further in my answer here, and not just say that human beings and machines both have their virtues. I think there's something really exciting about working with the machine learning on these sorts of problems. When you're a human being and you're cataloging seals and working through these problems of dating, it is really easy to sort of slip into sort of habits or conventions. And the machine offers you another way of thinking about the problem, fundamentally, a different way. And so you can look at it and go, well, this is just different. Maybe there's an idea here, a way of thinking about this that a human brain wouldn't have ever invented. So I can maybe learn from this and improve the way in which I do my things. And maybe as a final remark, I love the fact that the machine learning documents how it does things. So you can, it's repeatable. Like if you look at a printed catalog of seal matrices, they will never tell you in detail their reasoning. It's never possible to convey that kind of information in a catalog. It just wouldn't fit. But the machine learning algorithm, you can always, with the decision tree regressor algorithm, you can retrace exactly what its steps were, and you can preserve that so that you can see exactly how it is thinking about the problem.
Cool, thank you. That last point is really important. Yeah, thank you.
Yeah, and if I can say half a thing regarding that very last point, which opens a can of worms if you are dealing also like with the other part of the Middle Ages, where it's I mean, as Alessio said at the very beginning, if I'm not mistaken, that there's no handbook of Byzantine sigillography, which is a bold statement, but I mean, we really do not have some guidance from experts, in a way, from scholars, where they tell us how to date our matrices, right? So just like John just said, I mean, we can appreciate the style of lettering, the kind of iconography, and make very fine dating, but for example, something that I mean, once again, it is not you cannot reproduce the train of thought that went into your head dating that seal to 1204 to 1206, whatever. Of course, unless it is attached to a document, and in our case, as Alessio said, it's extremely rare. Or if you can pinpoint the seal issuer with precisely dated other historical sources. Anyway, and that's something, I mean, I just wanted to make a remark related to that. That, for example, something that not the Sigidoc schema offers, but also the Epidoc one. So I mean, something that we took from Epidoc, like pretty much 1-to-1. We just changed the values of the subtype is the dating criteria. So why we are dating something the way we are, and this is something that of course already is extremely important for epigraphy. And but for sigillography, we also have like another aspect. As John said, these are archaeological objects without context. So it's always very tricky to tell how to date something, and very often we have to give very broad and general dating criteria, but at least it's documented. So if we can't be extremely precise, and we often have to date to the century or to half a century, because very often it's not possible to to do more, right? But I would very be interested in applying the decision trees to a closed set of dated Byzantine seals. And yeah, I think it would be, we would get surprising results. I'm quite sure about that. And yeah, so perhaps when we have a set of seals which are encoded in sigillographic and which are precisely dated, might be interesting to to create a list of of criteria, right? To that of questions, if I understood the decision tree correctly, that should guide the machine towards a more precise dating. Yeah, that's amazing. So this is to say, we will contact you at some point, and it should be interesting.
Yeah, fundamentally, you just need a spreadsheet. You need a spreadsheet with columns that describe various features of your seals in terms of numbers, generally. That makes it easier. And then you tell it what column you want it to predict, and it does its thing. So get a spreadsheet. Once you have a spreadsheet, we can roll.
Yeah, and I think that, sorry to back up half a second, I think we should get, a couple of people to think about what kind of criteria we should use, what kind of questions we should ask, because I think that if we put four Byzantine sigillographers in a room, they will not agree on the questions to be asked. So let's see how it goes. But definitely I will do that. Yeah, but sorry, Gabby, I got you. Yeah.
Well, I was just, is there any semi-codified or entirely codified way to record in abbreviated or otherwise in referenceable form those decision trees, such that, for example, we could say in the dating criteria attribute, an ID which would point you to an online representation of that decision tree? Because capturing that information for an audience sounds absolutely essential.
Yes, the reason why I chose the decision tree regressor algorithm to work with was partly because it is so easy to document. Many of the other machine learning processes they call them black box. And so the actual decision-making process is not easy for anyone to discern. But decision trees are what they call, I think it's like a white box. And the output is a graph with those decisions. And it's a JPEG file. You can print it off and stick it on your wall. Now, every time I add new data, I rerun it, and I make a new tree, and it shifts a little bit. So you're constantly iterating, but you can save all that data very easily and make it available to people. And in theory, you could go in and manually tweak it. You could say, well, computer, you are using size here far too much. Please also deal with this. And you could create your own decision tree. You could do it manually, in fact. You could go home if you wanted to work on this problem with some Post-it notes and create a decision tree, put it up on your wall, and kind of work through your own, making evident your own thinking about a complex problem, such as how it is that I go about deciding what the date is for my seal.
Yeah, if I may add something, what I really appreciate in John's approach is comparing to some projects which are ongoing right now, applying artificial intelligence to this kind of material. To Byzantine seals in our cases, whose aim is also to find a automatic, let's say, a way to date, to read, to see what kind of iconography is there on a seal. The feeling with this kind of approach is to reduce our data to food for algorithms, and the algorithm will give an answer, but honestly, it's difficult for me, not an expert in the field, to find why. Actually, I've got this answer, and this is for me a scientific problem. Not to be able to do the path on the other way. It's a scientific problem for me, but maybe I'm overestimating the issue.
I actually really think that what you're saying is, I mean, very important. I mean, we always, I mean, in terms of sigillagraphers, and I mean, always preach like we should be transparent, and decisions and dating are not made from the guts. They actually follow a very precise train of thought. And of course, the more seals, the more inscriptions, the more whatever you see, the easier it comes to you. But it is not that it comes easy because your gut is telling you that it comes easy because you gathered experience and so on and so forth. So and I mean, I think that part of the Middle Ages from the East. We should definitely at some point sit and, we kind of did that for Sigilla, and think about, I mean, how we date things and make them reproducible, and because something like that has been made by Nicola Sigillogaphic in Alessio, correct me if I'm wrong, in the 90s. So in his book, Dated Lead Seals, something like that. I mean, an attempt to give some directions on how to date seals has been made. But first of all, these are all seals which are attached to documents, so the exceptions of the exceptions. And also the dating is mostly paleographic. So the reasoning behind that is limited. So I think we should, I mean, we all have like gut feelings in a way in terms on how we date things, not only seals. But I think it's like a scientific issue to just sit with yourself and think why this is the 3rd, 4th of the 11th century and not the 2nd. So yeah, and once we have some kind of answers to that, I will definitely create a spreadsheet and and as Gabby said once for the EPIDO guidelines, to print it on my on my pillow and sleep on it so that it will go into my head. But yeah, sorry. Yeah.
May I add
we could go on and on about seals, but yet Monica, please.
One last comment for our audience and for our students. This last conversation among Martina, John, Gabriel, and Alessio, I think is very important. So going beyond seals and these specific problems and the decision tree. So please try to follow again, given that you have this YouTube video, because this discussion is important. This is the conversation which is a conversation of today, so our problem. So these issues, the role of the machine, the role of human beings, scholars, as Alessio said, so there is a scientific problem in, let's say, in understanding how the machine works, etc. So I think that this is really a nice summary, starting with a specific topic and field, Byzantine studies, medieval studies, and then specific objects and, let's say, solutions, or code, etc. I think is a nice summary of the discussion that we have today in our communities, in the humanities, in computer science, in artificial intelligence, which is an expression used a lot. So I think it's just a recommendation for the students. Try to listen again this discussion. I'm not a Byzantinist, and a medievalist, but I appreciated this discussion, this final discussion of the session, because this is a nice summary of current questions we have in our communities. I shut up now. It's 6:30. I don't know if you want to say 2 words about the exercise. I don't know.
The exercise, yeah, I think one exercise is still pending, so bear with me, but you will be able to see that on the session page later. But otherwise, I mean, both the exercise that is there and also the other one that is coming, they are both actually you have to make let's say a deep dive into yourself and think about either decision trees or Athena Ruby. So the way your understanding of the diplomatic would work. And once again, as we say every week, if you are a student of mine in this semester or of any other tutor in the upcoming semesters, please check in with your teacher and or tutor to see if the exercises are optional or not. Having said that, I think I will say a word regarding our next and last session. So our semester has sadly come to an end, and we will meet next Monday at the same time, and we're going to have a very interesting session about digital approaches to Arabic and Georgian and Armenian sources for Byzantine and medieval history. So we're also going to talk about Epidoc, about inscriptions, and yeah, it's going to be quite interesting. So thank you. First of all, thank you, John and Alessio, and thank you to the audience. Bravi. And I will see you all next week. Thank you. Bye-bye.
Thanks. Bye.